Attitude instrument flying is the technique of controlling your airplane by using the flight instruments rather than outside visual references. It involves establishing a precise attitude for a given power setting, and then maintaining that attitude by reference to the flight instruments. When a change in the airplane's attitude is required, initially make the change by referring to the attitude indicator. Then scan the other instruments as needed for verification. For example, besides the attitude indicator, any change in bank is apparent on the heading indicator and turn coordinator. Pitch changes can be seen on the attitude indicator, altimeter, VSI, and airspeed indicator. Let's take a look at some of the basic maneuvers using instrument references, beginning with straight and level flight. For this maneuver, you need to control both heading and altitude. To maintain the desired heading, establish a wings level attitude on the attitude indicator. Then, monitor the bank instruments for any deviation. If you drift off your desired heading, adjust the attitude indicator to a bank angle that will correct the deviation. You should use a bank angle that equals the number of degrees of correction, as long as it doesn't exceed a standard rate turn. For example, if you're 10 degrees off your desired heading, you should use a bank of 10 degrees to get back on course. In straight and level flight, maintain altitude by establishing the appropriate pitch on the attitude indicator. Normally, the miniature airplane is aligned with the artificial horizon. However, if you increase the airspeed while maintaining level flight, the miniature airplane will be below the horizon. At slower airspeeds, it is above. After you've established level flight for a particular airspeed, you should reset the miniature airplane so it is on the horizon. After the correct attitude has been established, confirm level flight by referring to the altimeter, vertical speed indicator, and airspeed indicator. If your altitude starts to change, look at the VSI to determine the rate of the change. A small rate change will only require a minor correction. You should also check the airspeed indicator to see how the pitch change has affected the airspeed. If the airspeed is extremely fast or slow, you'll have to make a larger correction. When you have determined that a correction is necessary, stop the movement by adjusting the pitch attitude slightly. Then make the necessary adjustments to return to your desired altitude. Normally, if the altitude deviation is less than 100 feet, use a correction of a half bar width. If the deviation is greater than 100 feet, initially use a full bar width. Once the new pitch attitude is established, check the altimeter, vertical speed indicator, and the airspeed indicator to see that you have made the proper correction. Now let's take a look at turns. Most turns are performed at the standard rate of 3 degrees per second. As with straight and level flight, establish the bank using the attitude indicator. You can estimate the approximate bank by dividing your true airspeed by 10 and then adding 5. For example, if your true airspeed is 120 knots, you will be in a standard rate turn if your bank is approximately 17 degrees. You can verify that your turn is coordinated and that you're using the proper bank by referring to the turn coordinator. No matter what the airspeed, if the wing on the instrument is aligned with the mark and the ball is centered, you're in a standard rate turn. When established in the turn, the altimeter and VSI confirm your pitch attitude. If you observe a deviation, adjust the pitch on the attitude indicator and check the altimeter and VSI to see that you have made the proper correction. The airspeed indicator will directly indicate the need for a power change. During your instrument training, you will learn to make turns faster than standard rate. To do this, steepen the bank. As bank increases, the loss of vertical lift causes the aircraft to descend. To compensate, increase the pitch attitude and trim the aircraft. Scan the altimeter and VSI to confirm that your pitch adjustment is correct and that you're maintaining level flight. Since an airplane tends to slow down during a steep turn, you need to increase power to maintain airspeed. Remember to lead the rollout by 1/2 the bank angle. For example, if you're turning to 180 with a bank of 40 degrees, start your rollout at 200 degrees. As you begin the rollout, you need to reduce the pitch attitude and power to maintain level flight. Then retrim the aircraft. When changing altitudes in instrument flight, you should perform either a constant airspeed or constant rate climb or descent. To maintain a constant airspeed, initially adjust the pitch attitude of the airplane by referring to the attitude indicator. During this maneuver, you normally hold a constant power setting. However, if you desire to change the rate of descent or climb, you can vary the power. While performing the maneuver, monitor the airspeed indicator and make small adjustments in pitch attitude to maintain airspeed. Check your heading indicator and turn coordinator to verify straight, coordinated flight. Constant rate maneuvers are performed in a slightly different manner. In this case, the object of the maneuver is to establish a climb or descent at a constant rate. After establishing the approximate pitch and power settings using the attitude indicator and the throttle, verify the correct rate by referring to the vertical speed indicator. If a change occurs, you need to make an adjustment in the pitch attitude. With a constant rate maneuver, adjust the power to achieve the desired airspeed. Approaching your target altitude, use the 10% rule of thumb for leading your level off. In other words, if your descent rate is 500 feet per minute, start your level off 50 feet before your desired altitude. In IFR flight, you should be aware that because of spatial disorientation, you could get yourself into an unusual attitude. This usually occurs after you've been in a prolonged descending turn and then bring the airplane back to straight and level. This could result in a false sensation of being in a climbing turn in the opposite direction. When using instruments as your primary means of controlling the airplane, remember to trust your instruments. They are much more reliable than your senses, especially when there are no outside references. If you should observe a nose-high indication on the attitude indicator, a decreasing airspeed, a rapidly increasing altimeter, and a high climb rate on the VSI, you are in a nose-high, unusual attitude. Since preventing a stall is most important in this situation, you should immediately lower the nose while simultaneously adding power. If you are in a bank, you should roll the wings level. Another potentially dangerous situation occurs when the nose is too low. Here, excessive airspeed could lead to possible structural damage during the recovery. A nose-low indication on the attitude indicator, increasing airspeed, decreasing altitude, and a high descent rate on the VSI are all indications of a nose-low attitude. To correct this situation, simultaneously reduce power and roll the wings level. Then gently raise the nose to a level flight attitude. Flight instruments, like all mechanical things, are subject to malfunctions. Therefore, you need to know alternate sources for pitch, bank, and heading information if the main sources are inoperative. For example, suppose you notice that your aircraft's attitude indicator is showing a 5-degree bank to the right. However, the heading indicator is not moving. The turn coordinator indicates a left turn, which is confirmed by the magnetic compass. A check of the suction gauge indicates that there isn't sufficient vacuum to drive the gyros. If this happens, the indications on both the attitude and heading indicators are no longer reliable. To complete the flight, you'll have to use the other instruments. When flying partial panel, you must identify the inoperative instruments and omit them from your scan. If they become too distracting, you might find it helpful to cover the instrument faces. With the attitude indicator and the heading indicator no longer functional, your reference for bank information is now the turn coordinator. For pitch information, you must rely on your VSI, altimeter, and airspeed indicator. For heading information, use your magnetic compass. The compass, however, is susceptible to the forces of magnetic dip and acceleration errors and does not give reliable information during a turn. This necessitates the use of a timed turn to make a heading change. Remember, with the wing aligned on the turn coordinator, your rate of turn will be 3 degrees per second. You can use this figure to calculate how many seconds it will take to turn to a new heading. For example, let's say that you are on a heading of 270 degrees and want to turn to 180. That's a heading change of 90 degrees. At a turn rate of 3 degrees per second, it will take you 30 seconds to reach the new heading. After timing for 30 seconds, begin your rollout. When stabilized in level flight, read the magnetic compass. You may have to make small adjustments to get to the exact heading you desire. In this program, we have looked at some of the maneuvers you'll perform by reference to the flight instruments. Learning how to execute these maneuvers proficiently will greatly assist you when it comes time to start making instrument approaches.